Hello, math buddies! Today, we're going to learn about fundamental principle of counting. I am Cherdons and welcome to Math TV. Let us first define fundamental principle of counting. It says here, if one activity can be performed in P ways, and if, when it has been done, a second activity can be performed in Q ways, and when that has been done, a third can be performed in R ways, and so on. Then, the number of ways they can all be performed in the order stated is P times Q times R, and so on. For better understanding, let's have an example. Example number 1. An outfit for a model can be chosen from 5 blouses, 4 skirts, 3 stylish stockings, and 2 stiletto shoes. Question. How many possible combinations are there? Okay, how many events do we have? We have first blouses, the second one skirts, then stockings, and shoes. The number of choices we have for the blouse is 5, then 4 for skirts, 3 for stockings, and 2 for the shoes. From our definition, this is your P, Q, R, S. And what are we going to do? Basically, we're just going to multiply them and it will give us 120. Therefore, there are 120 combinations of outfit the model can choose from. Next, example number 2. The teacher is preparing a schedule for her master's degree class. Her choices, one of the 7 sections in calculus, then one of the 4 sections in philosophy, and last, one of the 2 sections in English. Determine the number of ways she can prepare her schedule. Okay, how many events do we have? First, calculus, then philosophy, and the last one, English. So, 7 choices for calculus, 4 choices for philosophy, and 2 choices for English. Again, what are we going to do? We're just going to multiply them. 7 times 4 times 2, it is equal to 56. Therefore, there are 56 ways the teacher can prepare the schedule. For example number 3, how many 3-digit numbers can be represented using numbers 0, 1, 2, 3, 4, and 5 if letter A, repetition is allowed, and letter B, repetition is not allowed? Okay, we have 0, 1, 2, 3, 4, and 5. For letter A, repetition is allowed. How many events do we have? We have 3 for 3-digit numbers. We have hundreds, tens, and ones. For the hundreds place, we cannot have 0 on it. We'll remove 0. Now, how many choices do we have for the hundreds place? Okay, let's count it. 1, 2, 3, 4, and 5. So we have 5. For the second place, which is tens, how many choices do we have? This time around, we're going to bring back 0 as one of the choices. So we have 6. Why? Because repetition of number is allowed. For the ones place, how many choices do we have? Again, because repetition is allowed, we have 6. Then, after that, we're just going to multiply it and it will give us 180 combinations. Example, for hundreds, we can have 1. For tens, we can choose 2. And for ones, we can have 1. Again, why? Because repetition is allowed. Another example, we can have 2, 0, 2. Next, we have 5, 4, 1. Now, let us solve letter B. Repetition is not allowed. Again, we have 3-digit numbers. For the hundreds place, we cannot put 0, so the choices will be 5. Let's have example and choose from the numbers 1 to 5. Let us have 1. So 1 is eliminated from the choices. And now we're going to include 0. So we have 5 for the tens place. Again, let us choose from the given available numbers. Let's try 0. So for the ones place, how many choices do we have? Correct, we have 4. So let's fill the last place and choose 2. As you can see, we don't have the same number because repetition is not allowed. Okay, let's multiply this. 5 times 5 times 4, it is equal to 100. So therefore, we can have 100 combinations of 3-digit numbers without repetition. 243 and 351 is included in the 100 combinations of 3-digit numbers without repetition. I hope you enjoy our discussion for today. See you again for our next lesson. Thank you. Have a nice day and God bless everyone.